So the thing about our solar system is that it has some really unusual phenomena in it that are difficult to explain. And here we're talking about phenomena involving orbits of certain objects. For example, certain objects, such as Sedna that you see right here, have such an unusual eccentric orbit that it's almost impossible to explain by using solar system formation models such as the famous NICE model. And while Sedna is just one of many different trans-Neptunian objects discovered in the last decade that seem to have these orbits that are just impossible to explain unless something else is out there in the solar system or something happened to the solar system a long time ago. And well, as you might have heard before, one of the major explanations that tried to tackle all of this involved a hypothetical Planet 9. A planet potentially orbiting somewhere on the outskirts of the solar system that might have influenced the orbits of these objects, eventually causing these orbits to become super eccentric. But after a decade of extremely thorough search, so far no signs of any planet has been discovered anywhere, which as a result led to some additional explanations or potentially alternative propositions. Maybe there is no Planet 9, and maybe even that NICE model is not totally complete. But how can these unusual orbits be explained without some kind of an object out there influencing them? Well, we do actually have a really intriguing paper now by Suzanne Pfalzner and her team that tries to explain this with essentially a stellar flyby. Or in essence, a visitation by another star, a really massive star, that possibly shifted everything in the solar system and caused certain objects to orbit in a certain way. And though this might sound like a kind of a really simple explanation, and maybe even just a little bit too far-fetched, here the evidence right now is actually really substantial. And so let's discuss this in more detail, but first by starting with facts and observational evidence from somewhere else. Okay, first of all, as of 2024, over 3,000 small objects have been discovered to orbit beyond Neptune. And surprisingly, a lot of these trans-Neptunian objects seem to have both eccentric and highly inclined orbits. Or basically they orbit in a very different way from most of the planets in the solar system. And in the original NICE model, this was all explained by having planets interact with various trans-Neptunian objects that actually formed much closer to the Sun, eventually scattering all of them outwards because of powerful gravitational interactions. And so in this model, the initial solar system was very compact and involved a somewhat thick disk. But here things don't actually make sense, because the resulting orbits would not match this. And there are so many of these TNOs discovered in just the last few years that seem to have these unusual orbits. As a matter of fact, in one of the most recent papers from just like 2 months ago, scientists using the Subaru telescope were able to discover 70 more TNOs in extremely faraway regions of the solar system, and all of them seem to possess unusual orbits. And though obviously before this was proposed to be signs of the Planet 9, today more and more evidence suggests that it's maybe something else. Now, this doesn't invalidate Planet 9 hypothesis just yet, but all these new discoveries do make it just a little bit less likely. And so the existence of various trans-Neptunian objects with high inclinations and peculiar orbits is extremely unlikely to be the product of just simple scattering by planets. Then, at the same time, we also have a lot of different observations of various early planetary systems, and of course various protoplanetary disks, with many actually showing signs of some kind of a star interaction, or essentially a stellar flyby. And here, even in somewhat low-density clusters, at least 1% of these objects experienced a flyby. But in most cases, such as for example in NGC 2244 or the Rosetta Nebula, this percentage seems to be anywhere from 8 to 15% for a typical star like our Sun. So essentially, out of all stars here, 15% seem to experience some kind of a flyby in the first 10 million years. And that's obviously because they actually form in really dense molecular clouds that contain a lot of stars nearby, where these encounters become very frequent. And so overall, these flybys are actually not as infrequent as researchers initially believed. But they do become less frequent as the star gets older, and of course, as it escapes the molecular cloud and as it goes on its own merry way. And so according to this study, based on all of these observations, for a star like our Sun, after 4.5 billion years, the likelihood for a flyby is somewhere between 20 to 30% in total. And here we're not just talking about a flyby at a distance of several light years, we're actually talking about a star entering the solar system and passing within 100 astronomical units away from the center. And though it's only 20 to 30% likelihood, based on the observations from the solar system, it looks like it might have happened here after all. And so here the researchers actually wanted to find out, so what would happen if star did fly by, and how would the solar system develop then? And to answer this question, they essentially ran various computer simulations involving 12,000 years of star formation and several different passages from different angles at different speeds and at different distances. And interestingly, here they were able to recreate certain parameters of the early solar system, including Sedna-like objects and various TNOs on highly inclined orbits. But these simulations produced something else. They produced retrograde objects, or basically TNOs or various objects moving in the opposite direction. And to the scientists behind this paper, at first implied that maybe their simulation was incorrect. But then they came upon studies where other researchers have actually found these retrograde TNOs, such as the object sometimes referred to as Niku. And intriguingly, this is not something that could be explained by objects like Planet 9, but is something that's explained in their simulation involving a flyby. And specifically, a flyby of a star approximately 80% the solar mass, passing within 110 astronomical units at an angle of 70 degrees. And here the results produced extremely similar orbits, including Sedna and all of the unusual TNOs, as well as you can see from this simulation, a lot of additional objects that still have not been discovered, but have now been technically predicted by this study, which suggests that there are so many more of these objects out there, which, if discovered, would confirm this hypothesis almost right away. But all of this would have to happen very early on, possibly within about 10 million years of the formation of the Sun. Intriguingly, if this is actually the case, maybe this could also explain why one of these objects eventually collided with the early Earth, leading to the formation of the Moon, with additional collisions happening around Venus, Mercury, Mars, and pretty much all of the other planets, including Uranus, that possibly received the largest collision so far. So basically, maybe here, all of these collisions were the result of this initial passage that disturbed a lot of objects and caused a lot of collisions over time. And on top of this, in a separate study, the scientists also proposed that quite a lot of retrograde moons of various planets may also be some of these TNOs that eventually got captured by planets over time. Quite a few of these exist around Jupiter and Saturn, and they do possess somewhat peculiar orbits. And since the observations from the Japanese Subaru telescope and even the observations from the New Horizons mission seem to provide more evidence for the existence of these unusual objects, even at faraway distances, at the moment this may not seem so far-fetched after all. And it's probably the Vera Rubin Observatory that's going to provide more evidence for all of this if it suddenly starts discovering more and more of these TNOs in certain locations, yet still does not discover Planet 9. But I guess one question that we cannot answer right now is, how likely did this also cause the collision of Theia and planet Earth? And did this flyby actually increase the chances for life to develop on planet Earth? In other words, do these flybys change the star system so much that it basically increases the chance for life to develop on one of the planets? Now, this is not something we're going to be answering anytime soon, but it is an intriguing question to ponder, especially once we get even more evidence with future telescopes. Until then, though, this is still just a hypothesis and just a proposition, and we're probably not going to know if this is correct for a very long time. As a matter of fact, it's probably going to be completely invalidated if Planet 9 is discovered after all. But until then, we can only speculate and make assumptions, although here the assumption is definitely really intriguing. And so once we have some updates or more discoveries, we'll come back and talk more about this in some of the future videos. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.